Air resistance. Now, Prince, please, when you join, kindly mute yourself. Let me mute all.
Oh yeah, you.
Okay, so we have two types of projectile motion: one-dimensional projectile motion and also two-dimensional projectile motion. And in one-dimensional projectile motion, the projectile, which is the object experiencing the projectile motion, makes an angle of 0 with the horizontal or the ground, one dimension, and two-dimensional projectile motion. In one dimension, theta is equal to 0. So the projectile or the velocity which actually shoots the object makes an angle of 0 with the horizontal. And here, theta is not 0. Class, can you hear me? Give me feedback to test my network.
Say yes, please. We can hear you.
Yes, sir.
In projectile motion, there are some assumptions which you must know. Without these assumptions, projectile motion cannot happen. One, the first assumption is that one, air resistance is neglected. Air resistance is neglected. So we can term this as one of the conditions on which projectile motion works. Air resistance must be neglected. And two, gravity does not affect projectile motion. Projectile motion horizontally. So when the body is moving along the horizontal, we assume that gravity does not affect the motion of the body. So these are the two main assumptions on which projectile motion actually works. All right, quickly, let's look at one-dimensional projectile motion. Then when we finish, we look at two-dimensional projectile motion. In fact, we discussed examples of projectile motion. So one-dimensional projectile motion example. When tennis ball is solidly hit, okay, with the racket, or when you throw a shot put, okay, when you throw a shot put, not javelin, we are looking at hitting tennis ball with a bat, a racket, and then throwing a shot put, one dimensional. So if this is the ground level, this is the tennis ball. The tennis ball makes a certain height from the ground. So when that initial velocity is given, so the initial velocity is u. the trajectory or the path of the ball will be such that it will go and drop to the ground. So it means that the horizontal is the ground. So look at it. This velocity u, and then a spiral to the horizontal ground. And so it implies that because the velocity given to the ball and the ground are parallel, it means theta is 0 degree. So clearly, this will fall under one-dimensional projectile motion. So class, whenever you are asked what pertains in one-dimensional projectile motion, the velocity of projection makes an angle of 0 degree with the horizontal. That is what defines one-dimensional projectile motion. Please, is there any question? Is there any question before I continue? Okay, silence means no question. We want to follow the path of the objects of the projectile. So, as the body falls, at one point it will be here, another point it will be here. Prince, are you there? Hello, Prince. Oh, Prince seems to have gone to the palace. Okay, so we want to
Yes.
follow the path. Okay, at one point it is here, at another point it is here, and finally drops to the ground. At just before it moves, t is equal to 0. Let's assume when it comes to this point, the time taken to come here is t1. So t1. This is t2. And the time taken for the body to drop to the ground is t3. Now, as the body moves, this is the reference, its starting point. It makes a vertical height h with the ground, from the ground. So h is that vertical height of the projectile from the ground. If when the body gets here and want to measure its horizontal displacement from the starting point. Horizontally, it started from this point. Please, are you with me? From the point O. If it's here and we want to measure how much this has been moved, displaced from its horizontal location, it is here. Let's assume this point is x1. Then when it was here, after time t2, we realize it has been displayed or displaced by this margin, this distance. So x2. First, at t1, we have x1. Then when it finally drops to the ground, we see the projectile being displaced by this amount or magnitude. This is x3. So class, it means that x1, x2, x3 are the horizontal displacements. Okay. How much the projectile has been moved or displaced from its starting point. So let me indicate something here. X1, X2, X3 are the horizontal displacement. horizontal displacement. Then equally, there is a vertical displacement. Vertically, this is its reference point. This is its position above the horizontal or the ground. As the body goes, we realize that at T1, the body seems to be displaced vertically by this margin, Y1. When it comes here, we realize that it seems to be displaced vertically by this margin, Y2. When it finally drops, okay, we also see it being vertically displaced by this margin, Y3. In fact, when it finally drops, the vertical displacement after T3 is equal to the height above the ground. So we also see a vertical displacement, Y1. So Y1, Y2, Y3 is also equal to the vertical displacement. So as the projectile moves, it seems to be displaced horizontally and vertically at the same time. Please, are we okay with this part? Class, are we fine? So as the body moves, drops to the ground, it seems to be displaced horizontally. It also seems to be displaced vertically. Now note that, please note that it takes the same time to, to cover a vertical displacement and then a horizontal displacement. What do I mean? You see, when a particle is here, we are saying that let the time taken the particle to be here be t1. So it would take the time t1 to make this vertical displacement y1, and it would take the same time to make the horizontal displacement x1. When it gets to this point, let's say we are saying that let the time taken to get to this point be t2. It takes t2 to make vertical displacement, and it takes y2. It also takes t2 to make the horizontal displacement x2. When it finally drops, it takes the time t3 to make this vertical displacement y3 and horizontal displacement x3. So it takes equal time to make a vertical and then a horizontal displacement. So it takes same time to make a vertical displacement and a corresponding and the corresponding horizontal displacement. And when you understand these things, realize that solving questions in projectile motion becomes so easy. Please, is there any question? Farida, Alvin, Abdul Rahman, Basit, Ajeman, Bridget. If you have a question, please ask. Class, can you hear me?
Please.
Okay. So it takes the same time to make, it will take T1 to make S1 and Y1, S2 and Y2. Okay. So we realize that as the body moves on or journeys, there is a vertical component of even displacement, and there will be a horizontal component of its displacement. And when displacement changes with time, it amounts to velocity. So we see a horizontal and vertical displacement. It would also amount to velocity vertically and horizontally because the displacement gets changed with time. So in projectile motion, we analyze the motion both horizontally and vertically. So quickly, let's look at horizontal analysis of the body's motion. So why are we analyzing it horizontally and vertically? This is because as the body moves on, we see it making a vertical displacement and then a horizontal displacement. Meaning that to analyze the motion, you have to analyze it both horizontally and vertically. For projectile motion, the horizontal velocity is always constant. So for projectile motion, the initial horizontal velocity, horizontal is represented here by x. The initial velocity is equal to the final velocity. Initial horizontal velocity and final horizontal velocity. They are all equal to u. U is the velocity of projection. Now the question is, why is the velocity horizontally constant? Why is that constant? Can somebody help? For a projectile motion, why is its horizontal velocity constant? If somebody has actually read around something like that, Francis, I'm listening. Go ahead.
Yes, sir. So I think it's because air resistance and gravity is inactive.
Exactly. So the reason why the horizontal velocity is constant is that horizontally in projectile motion, the first assumption is that air resistance is neglected. We don't consider air resistance. Two, horizontally, gravity does not affect the motion of a projectile. So it is like all factors which will reduce the speed horizontally has been eliminated. Please write that down. Write that down. Why is it that in projectile motion, the horizontal velocity is constant? The horizontal velocity is constant because air resistance and gravity are eliminated or do not affect the motion horizontally. So this is the reason, or these are the reasons why the initial horizontal velocity is equal to the final velocity, and they are all equal to u. U is the velocity of projection given to the body to move. So if you are throwing a shot put, that force, the applied force, give it that velocity to move, and that is u. Okay. All right. So if horizontally resistance and gravity does not affect it, then the initial velocity will be equal to the final velocity, and they will all be equal to u, which is the velocity of projection. Now we know that velocity or speed is equal to distance time. Please help me make distance the subject from this equation. Why that? Help me make distance the subject from this equation. Please, let's be. Find out the speed or velocity is equal to distance traveled over time taken. Help me make distance the subject from the equation. Okay, Abdul Rahman. Okay, Alexander is ready. Alexander, take over.
F is equal to V times P.
So S will be equal to V times T. Thank you. What this means is that because this velocity is constant, if velocity is constant, what is the value of acceleration? If velocity is constant, what will be the value of acceleration? Please go ahead. If you are ready, answer. If velocity is constant, what will be the value of acceleration?
Zero.
That will be zero. Good. So if velocity, horizontal velocity is constant, it means if I want to calculate horizontal distance, it will be the product of the velocity and the time. Darius, do you have a question? Darius, your line is very, very faint. Okay. So if I want this horizontal distance x1, x2, x3, it is saying that x1 will be a product of the constant velocity u and the time taken to get to this point, which is t1. If I want x2, the horizontal distance x2 would also be equal to the constant velocity u times the time taken to get to this point, t2. If I want x3 would be equal to the constant velocity times t3. Now, x1, x2, x3. So this displacement or horizontal distances is the greatest. Which one is the greatest? Class, which one is the greatest? Anybody can answer, please. X3 is the largest or the greatest horizontal distance. In projectile motion, the maximum horizontal distance traveled is given the name range. So here S3 is the range. S3 is the range. So the range R will be equal to the constant horizontal velocity times the time taken to reach it. Then if we look at T1, T2, T3, T3 would also be the largest. And T3 is also given the name time of flight. So this where R is equal to the range. The range is the total horizontal distance traveled. And T is equal to the time of flight. The time of flight is the total time taken during the whole flight or journey of the projectile. Okay. So if you're asked to calculate for the range is equal to the constant horizontal velocity times the time of flight. Please, is there any question? Is there any question? Please ask questions. Ask questions to understand very well. Now I'm going to set a question just to deepen our understanding at this point before we continue. So this is the motion of a projectile it is the projectile is at a distance of 100 meters above the ground. T1 is equal to 2 seconds. This is T2, 3 seconds. And T3, this is 4. The velocity of projection U, this is 20 meter per second. If this is X1, this is X2. Determine X1, X2, and the range. Determine X1, X2, and the range. Start where? Try it out.
Sir, please, U is equal
U
to what?
is 20 meters per second.
Okay, sir, thank you.
Welcome. U is 20 meters per second. Determine X1, X2, and the range. I'm taking attendance, so you must finish by now. I'm coming. We'll discuss it. Okay, Zion. Okay, Abdurrahman, rather. Abdurrahman, what have you obtained for X1?
The X1 had 40 meters per second square.
Of course, it will be 40.
Yes, sir.
Any horizontal distance is a product of the constant horizontal velocity and the time. X2, Ajewa,
I had 60.
that is 60. Please, while we discuss, be marking yourselves. And what about the range? What about the range? Yes, Zion. Zion, what did you make for the range? Hey, Franca. Okay, I am Alexander. Go ahead.
Please, I got 18 meter per second square.
So the constant horizontal velocity times 40, that's 80. Thank you so much. So this is how to calculate the horizontal displacement for one-dimensional projectile motion. Now, as I said, we see the body's displacement changing. X1, you saw that X1 is greater than, X1 is less than X2, X2 is also less than X3. Once displacement changes, okay, here it does not affect the velocity. The velocity is constant. So we realize that the horizontal distance depends on the time. How is just directly proportional to the time. Because U is constant, it only depends on the time. When the time increases, R will also increase. So displacement depends on time. Velocity is constant. How would you describe the acceleration of the body horizontally? How will you describe the acceleration of the body horizontally? Yes, anybody? What is the acceleration of the body horizontally? Alexandra, your hand is up. What is the acceleration of the body horizontally? Oh, it was an old hand. Dodu, come here. Francis.
Find product inspiration. Why not do it in seconds with AI?
And
This
zero.
is a tool called Oxio.
The acceleration is zero. This is because horizontally the velocity does not change. It's constant. Okay. So horizontally acceleration is velocity is constant. Acceleration is zero, and the displacement depends on the time. Okay. Let's quickly look at vertical analysis. We've analyzed displacement, velocity, acceleration horizontally. Let's look at its vertical analysis. So it's vertical. We are analyzing displacement, velocity, and acceleration of the body vertically whilst it drops. Vertically, the initial velocity is equal to zero. Vertically, the initial vertical velocity, we are representing anything vertical by y-axis. So the initial vertical velocity is equal to zero. Can somebody tell us why the initial velocity is zero, Francis?
Because like, when it's being projected at first, it's being shot horizontally.
Exactly. This is sure. You see, so and it's like throwing shot put. You hold it, you shoot it horizontally. So the velocity which is actually moving the body, its direction is 100% horizontal and nothing vertical. If this is what I'm pushing this horizontally. So initially, the velocity is 100% horizontal component and zero vertical component, unless you are pushing it down. Okay. So the initial horizontal velocity The initial vertical velocity is 0 because it is being shot horizontally. Okay, so because projectile is shot horizontally, so the trajectory or the path is such as it is here. Initially, this is where it is going. But as time goes by, because of gravity, then it will be pushing it down. So it drops. So initially, the velocity is 100%. So that's why the vertical component is 0. Class, are we okay? There you are,
Yes, sir.
and the rest of you. Okay. So if the initial velocity, the initial vertical velocity is 0, then vertically, because the object is within the gravitational field, you cannot take force of gravity from it. And it is the reason why, as the object goes by, it will be pulling it down. It will be here, it will be here, and finally will drop. So if I want the velocity after any time t, how do I determine that? Using v is equal to u plus gt, I can determine the velocity at the position 1, 2, and just before it drops to the ground. Meaning V1 would be equal to U is 0. So J times T1. When it gets to this point, and I want to find the velocity there, V2, this will be equal to, because U is 0, J times T2. Just before it drops to the ground, V3 would be equal to J times the time of flight. So generally, one of the ways to determine the vertical velocity of the projectile, one of the ways of determining the vertical velocity is by using V is equal to Gt. So this will depend on the time because gravity is constant. Acceleration due to gravity is constant. Please, is that okay? Then another way of determining the vertical velocity is using v squared is equal to u squared plus 2jh instead of s. I'm using h because we are talking about vertical height traveled. Because u is 0, v squared will be equal to 2jh. Therefore, v is equal to the square root of 2gh. What does it mean? This equation also depends on the square root of the vertical height. So v is directly proportional to square root of h. It depends on the vertical height. What does it mean? What it means is that if I want to also find the velocity at this point, then v1 would also be equal to square root of 2j times that vertical height, vertical displacement traveled, y1. If I want v2, v2 is also square root of 2j y2. And the maximum vertical height can V3 just before it drops to the ground. This can also be square root of 2gh or square root of 2jy3. So this is also used for calculating velocity, vertical velocity as the body falls. But this is height dependent, whereas the other first one is time dependent. So we can use either V is equal to GT or square root of 2GH for anything vertical velocity. Now note that as the body falls, it would accelerate, meaning this speed V1, V2, V3 would increase with time. And so vertically, the body accelerates. Horizontally, acceleration is 0. Class, is there any question? These days, you don't ask questions, and I'm not happy with that. All right. The next thing I want us to look at is the vertical height traveled. The vertical height traveled. Using h is equal to ut plus half jt squared, we can determine the vertical displacement y1, y2, and all that. So if you want y1, which we can also call as h1, y1 will be, because u is 0, we have half jt squared. Y2 would also be half jt2 squared. Y3 or h would therefore be equal to half j times the time of flight squared. Meaning that anything vertical displacement is given by h is equal to half gt squared. Please note that it takes the same time to cover a horizontal distance and a vertical distance. So when you pay r is equal to ut, this t in the range equation is the same as the value of t in this equation. It takes equal time to cover a vertical distance and then a horizontal distance. Okay. And when you understand some of these things, in fact, solving problems in projectile motion is very, very simple. Let's solve an example. Class, are you ready? I'm reading. Are you there?
Yes, sir.
Yes, sir.
Okay, so a ball is positioned at the top of a tower. A ball is positioned at the top of a tower 90-meter high. A ball positioned at the top of a tower 90-meter high is thrown horizontally with a velocity of 25 meter per second. It's thrown horizontally at a velocity of 25 meter per second. How far away How far away from the tower on the ground does the ball hit? How far away from the tower on the ground does the ball hit? I'm repeating. A ball positioned at the top of a tower 90-meter high is thrown horizontally with a velocity of 25 meters per second. How far away from the tower on the ground does the ball hit? Take G to be equal to 10 meters per second squared. Take G to be 10 meters per second. So 2 minutes. Right. Within 2 minutes, it's 2:21. Start work. Two minutes is over. Share your answers with me. Share your answers with me. Yes. So how far away from the tower on the ground does the ball hit? How far away from the tower on the ground does the ball hit? Yes. Anyone to share answers?
6 meters.
Come again.
106 meters.
106. Okay, we shall see. Any different answer? Pascaline,
Yes,
very far.
sir.
What's your answer? What have you also had? Okay, so let's go through it. A ball a ball positioned at the top of a tower, 90-meter high. So, from the ground to the top of the tower, if there's the ground, we are told that the tower is 90-meter high from the ground, and the wall is on top of the tower, and it's thrown horizontally with a speed of 20 meters per second. So the velocity of projection is 25 meters per second. So it is given a velocity of projection of this margin. How far away from the tower on the ground does the ball hit? So when it finally drops to the ground, assuming it drops here, how far away from the tower does it hit on the ground? So X. And clearly, this is the range. It's a question which demands the range of the projectile. Okay. And we've just learned that range is equal to the velocity of projection times the time of flight. Do we have U? Yes, we have U. Do we have the time of flight? No, we don't have. So how do we determine the time of flight to enable us calculate the total horizontal distance traveled? There's one thing that we know, and that is it takes the same time to cover a horizontal distance and then its corresponding vertical distance. Note if the height of the tower is 90, this distance will also be 90. It's vertical. The vertical displacement of the body at this point will also be 90. And we just learned that if you want any vertical height, h is equal to half j/t squared. This vertical displacement we know 90 is equal to half times, we're given G value of 10 times T squared. Therefore, T squared is equal to 18, 9 times 2. And what is the square root of 18? 3 root 2. Give me 3 root 2 in decimal. Give me 3 root 2 in decimal.
4.242.
4.242. Thank you. Seconds. So once we have the time of flight, okay, it takes the same time to cover this vertical height and then this horizontal distance. So the range would also be equal to 25 times 4.242. What is 25 times 4.2? It should be 100. And what's the answer? 100 and what?
106.05.
106.05. So approximately 106 meter. So I think is that Prince? Whoever gave us the answer is correct. Let me see by hand those of you who got the same answer. If you got the same value, raise up your hand. Okay. Francis got it. And then okay, Farida, Sean, Justin. Oh, okay. A lot of you got it. Oh, thanks. Thank you. Thanks for making me proud. Another question. Another question. Let me drop this question on the page. Russell, are you here?
Yes, sir.
Hi. That I think that same question I gave to you.
Yeah.
Last a minute, I'm coming. Good. The question is on the page. Let's attempt. Okay, let's attempt question 1, 2. Question 1 is similar to this very one we solved. And it says that in the diagram above, and the diagram is there, please, have we all seen the question? It is on the page, so check on the page. This time around, the projectile is 150 meter above the ground. So in the diagram above, a ball placed on top of a tower 150 meter high escaped with a velocity of 20 meter per second to hit the ground at a distance as shown above. Determine the value of x. Determine the value of x. And clearly, s is the range because from the diagram, the ball is on the ground, and that will be x will be the total horizontal distance covered. So find the rate. Simple question. Let's see. Then in the next question, a ball is tossed horizontally with a velocity of 15 meter per second from a height of 100 meter above the ground. Take G to be 9.8 meter per second. Take how long will it take the ball to hit the ground? How long will it take the ball to hit the ground? The time of flight. Then I. What are the horizontal and vertical components of the ball's velocity as it strikes the ground? What are the ball's horizontal and vertical velocity as it strikes the ground? I. How far did the ball travel horizontally in its flight? And the last one, what is the magnitude of the resultant velocity vector as the ball strikes the ground? Yes. Try this too. I'll use the occasion to teach something else. So class, start with 2 questions. Question 1 is very simple. So I'll give you 6 minutes. 6 minutes. It's 14:32. 35. So 2:35. Start with. We'll discuss it right after the time. In the diagram above, a ball placed on top of a tower 150-meter high is kicked with a velocity of 25. So h is 150. H, which is the height above the ground, 150. It is kicked with an initial velocity of 20. We are asked to take J as 9.8. So please, okay, J is 10. This is what's NOVDEC 2022 question. So usually pay attention to the value of J given. If they give you 10 and you use 9.8, it will affect your answer and the other way around. So determine S. S is the range. Okay. S is the range. This is S. And this is 150. If it's the ball is kicked with this velocity of 20 meter per second. So S will be equal to the constant horizontal velocity times the time of flight. The time of flight is a bone of contention here. So using H is equal to half JT squared, you can easily find that and then substitute into. So 150 is equal to half times 10 times T squared. Okay. So you have T squared is equal to 30. What's the square root of 30? What's the square root of 30?
5.5.
5.5.
7.
So 5.50 seconds. And so if this is the time of flight, and so S will be equal to 20 times 5.5. What is 20 times 5.5?
110.
Or 110 meters. In fact, everybody must get this correct. Show by hands. Sensors. Show by hands. I'm interested in those of you who managed to get this right. I want to see about 50 hands being raised. Hey, it's up to, I raise them. I'm seeing 25, 26, 27, 28, 29, 30. Okay. All right. Thank you. I saw up to 31. All right. Thank you. Then question 2.
Sir, please, I have a question.
All right. Ask.
I have a question.
Yes,
Sir.
I love your questions. Yes.
The time.
Mhm.
You guys rounded it to 1 decimal point, but I did it 5.477. So my answer was 109.54 meters.
109,
0.54 meters.
approximately 110. You are correct.
Okay, sir.
Yes. Is there any Franca? Do you have any question or Pascaline?
Sir, please, that was the previous one.
Okay. All right. Then let's move on to the second question. Stephanie, are you here? Stephanie and Sharon. Okay. While there is silence. Okay, so the ball is tossed horizontally with a velocity of 15 meter per second. So once there is a statement that it is tossed horizontally, then it is one-dimensional projectile motion. It is tossed horizontally. Then this is the direction of the velocity given to it. Horizontally, it makes an angle of 0 to the horizontal. So information that will depict that this is one-dimensional or two, that's it. And we are told this is 15. And this is 100. And this time around, we are asked to take J to be 9.81 meter per second squared. So the moment you use 10, you are digging your own grave. So how long will it take the ball to hit the ground? What does the question imply? How long does it take? Will it take the ball to hit the ground? What's the implication of the question? Yes, before we even solve it. Yes, Abdul Rahman.
They to find the time.
But which time? Which
The,
time?
the time
Finding
the time the ball
to hit
hits the
ground.
ground.
But I gave it a particular name. I gave it a name. Prince, go ahead.
Range.
No. I gave, you see, the total time that will be taken for the body to drop on the ground. Ejiwa,
Is it the time of flight?
the time of flight. Time of flight. The time of flight is the total time taken to make the whole journey. The range price is the total horizontal distance traveled. Okay. So clearly the question seeks the time of flight. Now, if we use R, range is equal to U times T. We don't know the range, and so we cannot find the time of flight. We have to use H is equal to half JT squared. Okay, H is known, 100. So 100 is equal to half times 9.81 times T squared. So we have T squared being equal to 200. Who is singing? Stop singing and solve my work for me. So what is 200 divided by 9.81? This will be 20, a little something a bit, something greater than 20. Right?
20
Do it for me. 200 divided by 9.81.
20.387.
24.
So we take 20.39.
Yes.
Do not run your values to 1 dp, at least 2 or 3. So 20.39, especially once we'll be using it to calculate for another. T therefore is equal to the square root of 20.39. What's the square root of this? Give it to me in 2 dp.
4.52.
4.52 seconds. So that's the time taken to hit on the, and you should get this. You should get this. Then the second question. Can somebody read the second question for me? The second question. Oh, Francis, Pascaline, and now I'm in front of you.
Sir, please, I have a question.
Okay.
How did you get a 200? 200 over 9.81.
Aida, I'll beat you. Aida, this is what I had. And I only was trying to make t squared a subject. So I cross multiply 100 times. If you multiply through by 2, this and this will cancel. You have 2 times. So 9.81 times t squared is equal to 200. Right? Are you okay?
Yes.
And you divide through by. Let me quickly address this. I've noticed in your assignment presentation that some of you are fond of presenting your answer instead of bringing variables before numbers. Now, 200 is equal to 9.81 t squared. You divide through by 9.81, and you have 20.BB is equal to t squared. And t squared, t is equal to 4 point. No, let the letter come before the number. And I saw that running across the assignments that I marked. I see that and I get annoyed. What kind of way is this? That is normal. This is an equal to sign. It doesn't matter the order. If it is inequality greater, that would be when you change it, that will be affected. But for inequality equal to, it doesn't affect the results. Is that clear? Then the second question: what are the horizontal and vertical components of the ball's velocity as it strikes the ground? What are the horizontal and the vertical components of the ball's velocity as it strikes the ground? Yes. Pascaline, what is your horizontal component of the ball's velocity as it strikes the ground? Pascaline.
Please,
Okay.
67.73 meters.
Come again. 67.
0.73 meters.
That's the horizontal velocity. Pascaline, how did you get this? How did you get this answer? Pascaline, are you there? Oh,
Yes, sir.
how did you get your answer? Or lottery? Okay. So just before, Francis, let me take this opportunity to explain this. You see, in projectile motion, when the body is here, just before it begins to move, the velocities acting, we have 100% horizontal, 0 vertical. So here y is 0 due to the direction. When it begins to move, at every point, there are two velocities acting on the body. The constant horizontal velocity, which does not change because L resistance is neglected and gravity does not affect motion horizontally. So the horizontal velocity acting on the body at every time will be constant, 15. The vertical velocity is time dependent. That is why we saw that V is GT or V is equal to square root of 2GH. These are all equations for vertical velocity at any. So note that at every position, the horizontal velocity is constant, 15. But the vertical velocity depends on time or this. So the horizontal velocity just before it hits on the ground will still be 15 meter per second. However, I guess I'm sure
Sir,
Pascalin's
please, I read the answer for the third one.
pardon?
I said I read the answer for the third one instead of the second one. The second question.
Okay, so what are the horizontal and then the vertical velocity components of? So the vertical velocity would be 9.81 times the time of flight. You had 4 points. 4 point what?
515.
Okay. So the product of these two would give us the vertical velocity at that point. Okay, class, are we okay?
Yes, please.
Okay, so this will be 44.34 meter per second. So horizontal velocity constant 15 meter per second, and the vertical velocity will be this. Then the third question is the resultant. The third question.
So please,
Hello.
I wasn't able to understand because I had a network issues.
Okay, so we are on the II. What are the horizontal and vertical components of the ball's velocity? Okay, at every point, you see when it moves, when just before it moves to this location, vertical is 15 meter per second. Sorry, horizontal is 15, vertical is 0. At every time, the horizontal velocity is constant. Okay, horizontally, the velocity is constant because of the reasons I gave you. And the vertical velocity at every time will be gt. So this will be gravity times the time of flight. And the time of flight, we have 4.52. So that will be the value of the vertical velocity when it just hits on the ground. Then how far did the ball travel horizontally in its flight? This is the time of the range. Okay, so Prince, this is the range, and we know the range. The range is equal to the constant horizontal velocity times the time of flight. So we have 15 times 4.52. And Pascaline is saying that that will be 67.73 meters. Please, are we okay?
Yes,
So be
sir.
marking yourselves. Then the last question, what is the magnitude of the resultant velocity vector as the ball strikes the ground? Now, when the ball, Sean,
I multiplied the 15 by the 4.5, so I got 67.8.
okay, that's correct. Okay, because of the approximation, it will affect the value. But anything, it should be around 60, 67 and some values. When the ball hits on the ground, the body has come to a stop. So that is why the question said just before the body hits the ground. Just before it hits the ground, there is a vertical velocity of 44.34. There is a constant horizontal velocity 15 meter per second. So it must be the result of these two. That's why the question said resultant. And when two forces or vectors in this manner, the resultant vector will act along the diagonal. This will be the resultant. And you can determine this using Pythagoras theorem. The resultant V becomes the hypotenuse. Okay. The horizontal is 15, the vertical is 44.34. So using Pythagoras theorem, V squared is equal to 15 squared plus 44.34 squared. V would therefore be equal to the square root of this. Francis, what will be the final answer?
It's 770.
Come again.
What is 6.770?
46.77, okay, meter per second. So this will be that resultant velocity vector. Okay. Sometimes other questions
Sir,
would ask, hello.
sir, please, I don't really understand what you just said. Like,
See, what
I don't
I'm saying
understand.
is that
There is
what
just
I'm saying is that at every point there are two velocities. Look at the path. When it is here, we only have the horizontal velocity, vertical is 0. But the moment it moves, there are two velocities, the constant horizontal one and time dependent vertical one. And if there are two velocities, you must find the resultant. Okay. And so we are determining the resultant using Pythagoras theorem. We have two vectors, one acting here and another one acting due west. So if you have a vector of this nature, you must resolve it into a rectangular component of vectors. We'll come to vectors. Okay, right after projectile motion, I think we must do vectors. Because vectors is very, very important. Francis,
Sir, Sir, please, can we use equal vectors to also solve this?
Yes. To get the resultant, you must use the concept of equal vectors. But because we haven't done vectors, that's why I'm not talking about it. Okay.
Okay.
So I think right after projectile motion, vectors will help you when you go to school. All right. So we resolve this into rectangular component, and it will form a right angle triangle. This part which we are looking for is the resultant. So the hypotenuse v squared is equal to, this is given as 15. We got this as 44. So v squared is 15 squared as 44.34 squared. And the result is 46.77. Let me add this one. Sometimes you can also be asked to find this angle, the angle the resultant vector makes with the horizontal. This angle, okay? This is the line of the resultant vector. At what angle does it make with the horizontal? And you can get that using either cosine or sine. Once the question is about this angle and you have the opposite and the adjacent, if you take tangents of that angle, it will be the opposite, which is 44.34 over the adjacent, which is the constant horizontal velocity of 15. Two, once you also know V, you can also use sine and cosine to determine the angle. And the results will be the same as either tan or sine. So that's it. That's it. Please, is there any question? Any other question? All right. If there's no question, I'll send you an example to try. Tomorrow we'll look at two-dimensional projectile motion. But I'll beg you, please find time to go over the one dimension today. Because when you understand this, you can easily understand the two-dimensional projectile motion. So class, I'm begging you, spend time to go over this. I'll send a related example to help you. Ishra, Binta.
Sir, please, will the video be posted? The
I
lesson
will.
video.
I'll do that.
Okay.
I'll
Thank
do
you,
that.
sir.
All right. So, all right. Oh, you hear from me. I'll pose the question to you to try your answer. All right. We'll end here. We have 4 minutes to time. So I'll give you the remaining 4 minutes to just go through what we've done for today. We'll continue tomorrow. Bye-bye to all of you. Okay. So see you. See you tomorrow.